Hey guys, and welcome back to a new video and a new playlist in which we will dive into the complex sea of Android storage. Make sure to bring your tissues, you will cry a lot here. This is really not easy. The Android team did not do a good job in terms of making storage easy, but that's why I am here. I will try my best to explain it as simple as I can, and yeah, you will basically understand and learn in this playlist, on the one hand, internal storage in Android, on the other hand, shared storage, so external storage, and on the other hand, scoped storage. I will design these different parts as independent from each other as possible. So if you, for example, don't want to learn about internal storage because you already know that, then you can skip this first video and just jump to the next one. We will still build this app here throughout all of these videos in this playlist, but you can always just get the source code for the corresponding video in the corresponding description. So what we will do here is we will make our own version of a gallery app. As you can already see, I have two devices here. This device runs on API level 28. This device runs on API level 30, so the latest one at the moment. And on the one hand, we have a private photo section and a shared photo section. The shared photo section here will just contain all the photos we made with our app and all the photos from this phone's gallery. So you can see when we are here on API level 28 and we minimize that, make a photo, open the camera, which is very, very laggy, but let's make a photo of this bookshelf and then go back into our app. Then you will see here is our bookshelf. So it will load the photos that we actually made with the external camera app. We can also choose to make our own photo here by clicking on this camera icon. Then a camera will open. We can make a photo of this different bookshelf. We can click on this check mark and then this photo will land in our app here. If we toggle the switch private here and make a photo, then you will see that this new photo will now be under our private photos. So that will be a photo that can't be read by any other apps. These shared photos can. As you can see, we made a photo with our camera here and it landed in our app. But here on API level 30, things just work a little bit differently because the Android team implemented scoped storage, which basically prevents your app from reading the files from other apps. So here we won't see the images made by the camera, instead only the photos we actually made in our own app. But how that really works, I will get into that in a later video. In this video, we will start to implement this internal storage section because that is actually the most easy one. One thing before I forget it is if we just long click on an image here, then we delete it. And here as well, we can also delete the images we actually made from the external camera. And here we can only delete our own images. Now, before you start, please take a look at this video's description, in which you will find the initial source code for this project. I already implemented the RecyclerView adapters. These are two adapters here. This one for internal storage photos and this one for shared photos, because I don't think I need to put that into this playlist. If you want to learn about RecyclerViews, then I have a video about that, but that is just a lot of boilerplate code. We don't need to go over here in this storage playlist. So all that happens here in these adapters is just, these images are loaded, the image URIs are loaded into the corresponding image view. We calculate the corresponding aspect ratio just to make sure that we also have that ratio in our staggered grid. And then we have that on long click listener, in which we will trigger a lambda function that we pass here in the constructor, which will just delete our photo later in our main activity. Then we have these shared storage photos, which is a data class, contains an ID of that photo, a name, width and height, the content URI where we can find that photo, and a boolean that we actually don't need here, so forget about that. And we have an internal storage photo that is a lot simpler, that contains just a name and a bitmap. And and our empty main activity. So now, assuming you have downloaded or just cloned my repository from GitHub in this video's description, we can actually start here in main activity. First thing first, let's implement view binding, private let init variable binding of type activity main binding, and just initialize that here before set content view. Activity main binding inflate and pass the layout inflator. Here we pass binding dot root. Okay, so internal storage. What actually is that and why do we need it? When do we need it? Internal storage is basically the private storage of your app. So no other app can access the internal storage of other apps unless your phone is rooted. So if you want to save sensitive data from your users, whatever, that does not belong into your database, for example, if you want to save images like we do here, maybe documents or just bigger files, then you do that in internal storage. Saving stuff in internal storage is very easy. We don't need any permissions. We will need permissions for external storage, but not for internal storage. So let's actually jump into it and start to write a function to save a photo. I will do that here in our activity. And by the way, this won't be the best example in terms of architecture, this app here. This is really only focusing on storage. So we will put all of our code into a main activity, no MVVM or whatever here. Let's write a private function, save photo to internal storage. This will take a file name, so just the name of the file of the photo, how we want to save it in internal storage and how we want to be able to load it later as well. And a bitmap, so the photo just in form of a bitmap, because that is the format in which we'll get the photo from our camera intent that we will send of type bitmap, and it will return a boolean whether that saving was successful or not. We can return try. Usually when we deal with storage, we want to surround our things here with try and catch, because there is a lot of stuff that can go wrong when dealing with storage and files. Usually what happens, usually what can happen is an IO exception. IO stands for in and out, in case you didn't know that. So basically everything related to data. In the catch block, I just want to print the stack trace and return false. And in the try block, we can now take our file name and our bitmap and save that in internal storage. So whenever we have a bunch of bytes basically, and a bitmap is nothing else than just a bunch of bytes, and we want to save these bytes, we need what is called an output stream. So there are two different types of streams. On the one hand, we have input streams and output streams, and there we again have this IO. I personally always confuse these two. So output stream is what we need here. So we basically have the bytes from our bitmap, and we just want to put them out in a file. And if we have an input stream, then we basically get the bytes from a file and we want to put them, for example, into a bitmap, into anything. We just want to define how we want to interpret these bytes, because bytes in the end are just a bunch of zeros and ones. And if we, as the programmer, don't define how Android should interpret these bytes, nobody else will. So that is basically the difference between these two types of streams. And so we will use an output stream here. We can reference that with open file output, in which we need to pass the name and a mode. The name will be our file name, and because we deal with images here, let's actually also append.jpg here. So file name.jpg, and the mode is mode private, which just means, okay, this file that is created here can only be accessed by this application here. Then we want to call .use, which is a Kotlin extension function specific to file streams. And what use basically does is, it is just a very helpful function that will immediately close our stream after we wrote to it or after an exception was thrown. So every time we have a stream, we always need to make sure to close that stream after using it. And that is what this function already does for us, so we don't need to deal with that. And we now get a file output stream here. We can reference with a stream. And now how do we get these bytes from our bitmap into this stream? Because this stream is now a file output stream. So we now want to take our bytes from our bitmap and put them out into this stream, into this file. And we can do that with a function from bitmap called compress. We want to check if bitmap.compress, which you can see returns a boolean, whether that compression was successful or not. If that is not successful, we just want to throw an exception here. And here we pass the format, which is bitmap, compress format, JPEG, quality, let's pass 95, and we need to pass the stream into which we want to compress that bitmap, into which we want to send these bytes from that bitmap, which is just our stream here. And if that fails, we will jump into that if condition, else we won't. Then we just throw an IO exception. Couldn't save bitmap. And then after that open file output, we just return true. The next function will be a function to load a photo from internal storage, which is pretty similar in terms of complexity. Private function load photo from internal storage. And this function will actually not load a single photo, instead it will load all photos at once that we saved with our app here in internal storage, and will then return a list of type internal storage photo. So if we remember here, this class just contains the name of that photo and the corresponding parsed bitmap. And I will actually make this a suspend function. Let's execute that in a coroutine, because we actually read a bunch of files here, a bunch of images, and we don't need to do that on the main thread. So we will return with context here. I want to switch to the IO dispatcher because we're dealing with files here with in and out operations. Now, to actually just get a list of all files we have in internal storage, we can just create a variable, val files, and set it equal to filesdir, so files directory, which refers to the root directory of our internal storage, and we can call that list files. You will see that returns an array out of files. And now that files variable here will contain all files from internal storage. How do we now make sure that we only get our images? For that, I want to filter that list. So we have files dot filter, and now we pass a condition that needs to be true for those files we want to keep. So on the one hand, we want to be sure that it can read, so that we can actually read from that file, otherwise we don't want to include it in the list. And if it is actually a file, and if it .name ends with JPEG. So we basically find all JPEG files in our internal storage. And then we simply call .map on that to map it into our custom internal storage photos here that we will display in our RecyclerView adapter. We will get the bytes from that corresponding file. You can see we just get references to these files. The bytes we simply get by using it.readBytes. It's really that easy, so that is just a byte array, just a bunch of zeros and ones. And now we want to take that byte array and just tell Android, hey, please interpret that byte array as a bitmap and save that into a bitmap. So val bitmap is equal to bitmap factory that decode byte array. Here we need to pass the data in terms of byte array, which is our bytes. The offset will be 0, and the length, so how many bytes we have, is just bytes, that's size. And then finally, to return in this map function, we will wrap that around an internal storage photo, which is our data class here, our data structure, where we can pass it, so our file, and the name from that file. And for the bitmap, we pass our bitmap. And we still get a warning here. Okay, it could be that files is null here. Let's add a null check, and here before map as well. And then after map, in case that is null, we simply return an empty list. And that is our load photos from internal storage function. And last but not least, we want to add a function to delete a file, which is the easiest function from these three. Let's do that here. Private function delete photo from internal storage, and here we just pass the file name we want to delete, and we'll return a boolean whether that deletion was successful or not. we can again just return a try and catch block. Just catch any type of exceptions here. And we also just want to print the stack trace and return false in case something goes wrong. In the try block, we simply want to call delete file. And here we pass the name of our file, which is file name. And this function will already return a boolean whether that deletion was successful or not. If you don't know how I get that documentation, just pressing Ctrl Q. So you can just see that this function will just return if the file was successfully deleted or not. And the last few things we need here is, on the one hand, a function that will load our photos from internal storage into our RecyclerView. And on the other hand, we need a function to be able to take a photo and simply save that in internal storage if we actually enable that little private switch. So let's write that here. Private function load photos from internal storage into RecyclerView. And that will just launch a coroutine. Launch, and here we just get the photos. Using our load photos from internal storage function. Then we use our RecyclerView adapter, which we don't have yet. Let's create that private late init variable internal storage photo adapter, this one. We will initialize that afterwards. So then we can just use that internal storage photo adapter, submit a new list, which is photos. Then let's quickly set up our RecyclerView, adding a function, set up internal storage RecyclerView, and that is equal to our binding RV private photos. That apply. We want to assign our adapter. Let's initialize that in onCreate. Here, internal storage photo adapter is equal to new internal storage photo adapter. And you can see we get a lambda function here, which will be triggered when we have a long click on that item and we get the corresponding photo we long clicked on. Then let's assign that adapter. Adapter is equal to internal storage photo adapter. And the layout manager will be a staggered grid layout manager to get that staggered grid, where we simply need to pass a span count and an orientation. Span count will be 3, so we have 3 columns in our grid, and the orientation will be RecyclerView.vertical. Then let's call these two functions after we initialized our adapter, set up internal storage RecyclerView, and load photos from internal storage into RecyclerView. So now how can we actually take a photo? For that I will use activity result contracts, which is kind of a new way to get activity results. Previously we needed to do that with the start activity for result function, which is now deprecated, I think. So we use these result launches, which at least come from this dependency I included here. This one, these two actually. And these make it a lot easier to get activity results. So let's see how that works. It's very simple. We just define such a contract. So that is just a contract between our application and the application we launch, which is in our case just the camera app. And the contract says, hey, I launched the camera app and the camera app delivers the corresponding photo. That is the contract. So let's call that take photo is equal to register for activity result, which will now take such a contract. We can get that using activity result contracts. That is just a collection of typical types of result intents here. And we want to have take picture preview. That will give us the bitmap of the photo that was taken from the camera. And then here we get a callback with that corresponding bitmap once the photo was taken. It's really that easy. When a photo was taken here, we first want to make sure if we want to save that photo privately in internal storage or in shared storage, which we'll implement in later videos. So val is private is equal to binding switch private is checked. So if that switch is simply checked, we say, hey, we want to save that in internal storage. So if is private, if that is true, we want to call our function save photo in internal storage. For the file name, I will just randomly generate one here using a UUID. So just a random UUID .toString, and we pass it here, which is our bitmap. And this function will actually now return if that saving was successful. So let's save that in a variable is saved successfully. And if it was saved successfully, we want to load our photos because we want to update our internal storage photos basically. So we say load photos from internal storage into RecyclerView. We also want to display a little toast.make text, photo saved successfully, toast.length short, and that show. We can copy this toast for the else case. So in case the saving was not successful, then we will just use the message failed to save photo. And now we only define that contract. We didn't really execute it. When do we want to execute it? Well, when we click on our photo icon. So here in our activity main layout, that is simply this little image view down here. When we click on that, we want to launch that contract and execute it. So let's add an on-click listener to that image view, binding button take photo, set on click listener, in which we will just use take photo dot launch, and we want to import launch here, and that is it. That is how easy we can actually execute these activity result contracts to get the result of another activity, of the camera activity. And you really have a lot of different contracts here. Get content, for example, or take pictures. Actually not what we want here. We can open documents, we can request permissions, which we'll also do here in this playlist, and just a lot more. We will take the take picture preview contract. And when we then long click on an image, on a photo, here we simply want to delete it. So delete photo from internal storage, and we pass it.name for the file name. And here we can actually also check if that deletion was successful. Is deletion successful? And then simply check that. We can actually just copy this if else block here, paste it here, rename this condition. If we successfully deleted it, we also want to load the photos into our RecyclerView again to update it, and replace this with photo deleted successfully. It's actually photo successfully deleted, and fail to delete photo. And then let's actually try out that app. I'll run it here on my emulator. And for internal storage, by the way, it totally doesn't matter on which API version you run it. That works the same on each version. So let's see. We want to toggle the switch to private. We want to click to make a photo. That works. Our camera app opens. Let's make a photo of this little cat. Click check. And you can see there's our photo. It was saved successfully. And if we now long click on that, you can see it was deleted. So it seems like everything is working fine. We can also make multiple photos. Let's check that as well. Like this. And then you can see these photos just get added to the RecyclerView. So I hope you really liked this first video of this playlist. In the next videos we will then dive a lot deeper into storage, into external storage, which is really a pain. But yeah, I will make it as simple as I can. And if you have any questions, then just put these into the comments. If you are looking for more advanced Android courses, check out the first link in this video's description, which will lead you to my website, and there you will just find more advanced premium courses that are also a way to support me and my work. And these will really take your skills to the next level, will make you a job-ready Android developer. Apart from that, I wish you really an awesome day. See you in the next video. Bye bye.